Hello everyone, this is Dimpal Dekaraja sir. Here I would like to give a lecture on implicit function rule. In the classes, you have already known about the function, that is different types of functions, that is explicit function and implicit function. The functions you have learned till now were the explicit function, where the dependent variables were explicitly given. But in case of implicit function, the dependent variable not explicitly given. Therefore, it is called implicit function. A definition is simply given here as for the implicit function. That is, it's a function where dependent and independent variable not explicitly given. For example, y minus x minus 10 equal to 0. This is a normal equation. But this normal equation also can be called as a implicit function or is a form of implicit function. If we write this implicit function in the general form, then it is written as fxy equal to 0. But you know that in case of explicit function, the function is written as y equal to fx, where the functional relation is symbolized by small f. But in case of implicit function, we symbolize it as capital F. But if we have a function where that explanatory variable have more than 1, then it can be written as fy x1 x2 to xm equal to 0. Now let's see how the implicit function rule applies. In the first semester classes, you have learned about the total and partial differential or total and partial differentiation. But in case of implicit function, that total and partial differentiation rules have to be applied. And therefore, here also, for this implicit function, that is fxy equal to 0, I have applied the total and partial differentiation or differential. Now, applying the total and partial differentiation in both sides of the above implicit function, I've got this relation. This del f by del x into dx plus del f by del y into dy equal to 0. Rewriting the relation, I've got this relation, that is del f by del y into dy equal to minus del f by del x into dx. And thus we get this relation dy by dx equal to minus del f by del x into del f by del y. Here del f by del x and del f by del y indicates the partial differentiation of the original function, that is fxy, with respect to x and y. These are the final relation. Now let us take an example. Here a numerical example given as y minus 5x square y plus x cube minus 8 equal to 0. Here we have to find out the dy by dx, that is derivative of y with respect to x. As you already learned it, for this to find out the derivative, we have to apply the total and partial derivatives. Now we know that dy by dx equal to minus fx by fy, where fx and fy is indicated as the partial derivative of the function with respect to x and y. Now taking partial differentiation of the original function, we'll get the fx and fy. First I have find out the fx in this way, taking partial derivatives. I got this relation. Thus finally I got this, that is minus 10xy plus 3x square, and this is the partial derivative of the function with respect to x. Now let's see for the case of fy. In case of fy, we have taken the derivative of the function with respect to y. And thus finally I got, that is 1 minus 5x square. This is the value of fy. Now putting this both the value, that is fx and fy, in the derivative, that is relation dy by dx equal to minus 10xy plus 3x square divided by 1 minus 5x square. And finally we have got this relation, that is dy by dx equal to 10xy minus 3x square divided by 1 minus 5x square. But here we have seen that y exists in the right hand side. But since we have find out the relation between dy y and x, that is derivative of y with respect to x, therefore y should not be exist in the right hand side. Now we have to remove this y, putting the value of y. Now how can we find out the value of y? We can find out the value of y from the original function. From the original function we have got this relation, that is y into 1 minus 5x square equal to 8 minus x square. Thus the value of y we get in this way, this y equal to 8 minus x cube divided by 1 minus 5x square. Now putting this value of y in the derivative form, we have got this relation. Thus the final value we get here, this dy by dx equal to 80x minus 3x square plus 5x to the power 4 divided by 1 minus 5x square whole square. Now let's see how does the implicit function rule applies in economic application. Before that, this is the problem given to you and solve it. Try to solve this problem at your home. Let's see the economic application. In case of comparative static, we can apply the general or the implicit function rule applies in case of comparative static. But in comparative static, where the functional forms are in general, that is general equilibrium relation case. In case of general equilibrium, we can apply this comparative implicit function rule. Here an example given is the demand is a function of price and income. This is the general market, and supply is a function of price. But the partial relation between demand and price is negative, and the partial relation between demand and income is positive. Similarly, the partial relation between supply and price is positive. That indicates the supply increases due to increase in price. Now putting this demand and supply function in the equilibrium form, we get this relation, that is d p y naught equal to sp. This is the equation 1 that can be called as the implicit form of the function. in this implicit form we can put the equilibrium price, value of equilibrium price. Thus, putting the equilibrium price where price is a function of income, we get this relation. Thus, equation 2 is the implicit function. In equation 2, we can apply the partial implicit function rule, that is from which we have to find out the relation between price and income. Thus, the relation between equilibrium price and income can be obtained as taking the partial differentiation of the function with respect to income and equilibrium price. Now, taking this partial differentiation, we get this relation that is shown in equation 3, where dp bar by dy naught equal to minus del d by del y naught divided by del d by del p bar minus ds by dp bar. Since we have given that partial relation between demand and price is negative and the partial relation between demand and income is positive, and also the partial relation between supply and price is positive, therefore we get this relation, that is the relation between price and income is positive. That indicates that equilibrium price increases due to increase in income, or if the income decrease, then equilibrium price also decrease. Now, what will be the situation if the quantity changes with respect to income? That is, change in equilibrium demand with respect to income, which we can get from this relation, that is from equilibrium demand and price relation and from the equilibrium price and income relation. But from this relation, we will get a negative value because the relation between demand and price is negative. But the equilibrium demand and equilibrium supply always same. Therefore, in place of equilibrium demand, we can put the equilibrium supply. And then we get this positive relation. That is, change in demand with respect to income is positive if we put supply in place of demand. Look at this relation. In the first line, that is dt bar divided dp bar. But in the second line, in place of demand, we have put the S bar, which indicates the equilibrium supply. Now I like to thank you all and look at this video carefully and also read the PDF file given to you about the implicit function, where the economic function also solved applying the implicit function rule. If there arise any question, please ask me. I will respond immediately. Thank you, everyone.